Well, welcome everybody. Thank you all for coming today to our big event. We've got a lot of interesting speakers and interesting content for you today, and I hope you find it really interesting and educational. Thanks to everybody who's also watching on the live stream, beyond the folks who are here at OSCON in Portland. I also want to pay a special thanks to all the sponsors who've helped us put this event on. At the back of the room, there's a number of tables, there's demo stations, there's some swag, some pretty cool bags I saw back on that corner that I want to make sure I grab one on the way out. So please, after we're done, make sure you take the time to check those out. Also want to pay a special thanks to the various companies and partners who've helped us by speaking today. People like Zulily and eBay and other companies that have really helped us put together this content. So thank you all for that. So with that, my name's Greg DeMichillie. I am a Director of Product Management at Google in the Cloud Platform. And my goal is to talk to you a little bit about sort of the origins of Kubernetes within Google, what we're trying to do with it. Then later we're going to have Eric Brewer, who's Vice President and Technical Fellow at Google, who's going to talk about our vision for how Kubernetes evolves. And then we're going to have Craig McLuckie come on, and he's going to talk about the community that we want to bring together, that we are bringing together to really guide the evolution of Kubernetes into the next step. So, you know, if you've paid any attention, you've heard a lot of discussions about these words, cloud-native applications. And you're going to hear more about this today. And I think the term gets confusing, and in my mind, it's actually pretty simple. During the 2000s, a lot of companies, Google, eBay, Twitter, companies like that, found that as their scale grew, that the existing ways of building and deploying applications just weren't sufficient. We saw applications, you know, the infamous whale fails, where architectures had to be rewritten over and over and over again with every order of magnitude of scale that companies encountered. And along the way, these companies realized through necessity and through stubbed toes that a new architecture, a new way of building applications was needed if we were going to serve global services at the scale that we were all trying to. New ways of building applications, new ways of managing applications. And then we've given that term cloud-native application. Now, at the end, what's really exciting now is those technologies that were originally purpose-built for a very small select set of companies like Google and eBay and Facebook. Those building blocks are now being brought to the world through open source projects so that everybody can benefit from these technologies and not only just the handful of companies with the large budgets and the large teams. And that's why it's really leading to a revolution, which is, I know, an overused word. But I think it's true in this case. If you look at technological revolutions that upend the way development is done, the move from mainframes to PCs completely changed the way we think about building applications. Client-server, again, changed the way we thought about applications. Mobile changed the way we thought about applications. I think the move to containers and container-based deployments and cloud-native apps is on the scale with any of those changes. So it really is one of these once-in-a-decade opportunities where new ways of building and new ways of developing are going to come along. It starts with this move away from worrying about physical resources. If you really dig into what most of us are doing in the cloud today, it's the same thing we've done on-prem, but in somebody else's data center. We're still managing servers in largely the same way. We're still deploying operating systems in largely the same way. We're building applications in largely the same way. We're getting cost benefit right because it's cheaper to rent somebody else's data center than operate our own. And we're getting better speed because I can provision new hardware with an API call instead of a purchase rec. But at the end of the day, it still feels kind of like the same thing I used to do. This revolution is one of those where we're going to move away from managing individual machines into managing applications. And we're going to talk more about that a little bit. It also affects not just the developer, it affects the operations people. If you think about the life today of developer and operations, it's grown incredibly complicated. Developers are constantly worrying about operational details like patching of operating systems. Ops people are constantly worried about inadvertently breaking applications. We need to get to a model that allows developers to innovate on applications and allows operations people to be efficient with operations without constantly stepping on each other. Now, what's that have to do with Google? Well, if I ask most of you what you think of when I say Google, you probably think of this picture, right? A white page, a search box. I type some text. In about 400 milliseconds, I get an answer. When I see this picture, what I see is this. I see data centers, many, many data centers, powered by servers and racks with a fabric network overlay, with a software stack. And it's that infrastructure, actually, that is the secret that's enabled Google to be as successful as it is. It's that infrastructure that's allowed us to do things like not just search, but Gmail and apps and YouTube and maps and photos now. It's that infrastructure, and more specifically, it's the software stack on top of that infrastructure that allows our developers to work at a very rapid pace without having to think about things like individual machines or individual networks. And that's what we're trying to do here. We are trying to give you that same freedom, that same capability that Google developers have. Whether you're using Google as your hosting environment, or whether you're going on-prem or using Azure or whatever hosting environment. So to see that, let's take a trip through the Wayback Machine. It's now 1998, and we're going to go back and look at what Google.com looked like, and we're going to sort of trace the evolution of how we came to this container-based system. Because we didn't start there. We got there through a series of learnings and mistakes along the way. So here's the first homepage for Google.com. Clearly, we hadn't hired a designer yet. And in fact, given the amount of traffic that we were serving at that point, this is our first cluster. It's not pretty, and in fact, it's small enough that if you think about it, how do you manage that sort of cluster? Well, you can name the machines, right? You know which ones are which. I know that 1 is on the left and 6 is on the right. So you don't need complicated systems for managing the machines. You don't need complicated systems for deployment. Even by the time we got to our first rack, which looks a little more traditional in that it does, in fact, look like a rack. If you look more closely, you'll notice that the circuit boards are sitting on cardboard, and there's corks separating the individual elements in the rack. And that's not just an amusing anecdote. The reason that's important is we learned early that you don't build highly reliable systems by buying quote-unquote reliable hardware, because there's no such thing. You build reliable systems by assuming the system is unreliable and building a software stack to manage that system. And that's what started us on this journey of building a software stack that allows our developers to deploy applications without regard to where they're running. Along the way, we eventually realized that as we grew, we needed a better software stack. And we had a very simple growth on that. We needed our developers to be as productive as they could possibly be. At this point, our developers are still managing individual machines. If you were to talk to the apps team or talk to the search team, they knew which machines were theirs. They had a pool of machines by name that were theirs. The apps team had theirs. They were each doing their own management of that infrastructure. If one of them had excess capacity, it wasn't of any use because they owned the machines. And so our developers ended up spending time on some pretty mundane, uninteresting details of the infrastructure. And so we had a goal, which was to free our developers from that, to let our developers build apps and let the system take care of the rest of the details. And the solution that we found was containers. And not just containers, but containers built to work at production scale. It's about letting you as a developer operate at a different level of abstraction. If you think about this, in some ways, this is about the observation that when you get large enough, a data center is not a collection of computers. A data center is a computer. It's one large system. And just like a computer has a scheduler, and what does a scheduler do? It takes a task and it finds a processor to run it on. We needed to build a system that allowed us to take containers and somewhere in the data center find a machine that had the RAM and the CPU available to run that job. And so we built a productionized container system that did just that. We've published research papers on it, and it's been called Borg. And Borg is the foundation of how we manage containers at Google. What Borg ultimately does is schedule containers onto machines, and it allows our developers not to think about machines. It allows our developers to just think about jobs and tasks. And that was the goal. Now, it had several important side benefits. One, it's scalable. And there's multiple dimensions to scalable. You know, when I say scalable, most of you probably think hardware scalability, right? Which is, as I double the number of servers, the system just works. And that's absolutely true. One of the aspects of a production container system is scalability. But the other thing is it allows us to scale our fleet much faster than we scale our team. At Google, we measure fleet sizes in terms of megawatts, right? How many megawatts is a given data center? And if you look at the period at which we switched over to container technology, we were able to grow our fleet size roughly an order of magnitude faster than we had to grow the operational people that took care of the fleet. And the reason is because they were freed from much of the boring work of allocating resources to groups and allocating resources to jobs, restarting jobs when hardware failed. That was all taken care of by our container management system. So a scalable system scales with hardware, allows you to scale much faster than you have to scale your operations team. And it provides a standard foundation for everything from health checking and monitoring and all of those sorts of technologies. So given our growth curve, scalability was clearly a requirement. The other is portability. Now, again, portability doesn't just mean cross-platform portability, because within Google, we have a fairly homogeneous environment, right? We run one software stack largely. But we run that stack in dev and test and staging and production. Now, I bet, again, if most of you dig into what's going on in your environments, at least an important part of your time is actually spent dealing with, well, it worked in testing, why didn't it work in staging? Or it worked in staging, or why did it fail in production? So portability between these different environments is a key goal, because you don't want to have to sit there and try to fix a borked deployment because the night before your big launch, your production system went down. The other thing of portability is it allows us to get much better utilization. It allows us to run many more workloads on fewer machines, because we can take advantage of slack anywhere in the environment. If we have unused capacity in one cell, we can place any job we want on that cell because the system gives us portability. We don't have to worry about, oh, wait, that software was built for this generation of hardware, this generation of system. So portability is a key requirement that we were looking for when we built out container management. And of course, and I've hit this multiple times, abstracted. If your developers are spending time thinking about individual machines, you're operating at too low level of an abstraction. You want to operate at the level of applications and let the system take care of the scheduling of the applications. That means your developers can move faster, you can ship faster, you can iterate faster, your business grows faster, speed improves everything. The result of all this is that as today, quite literally everything at Google runs in a container. And that's no exaggeration. Even our infrastructure as a service project, Compute Engine, which runs on VMs, itself runs in a container inside Google. Everything runs in a container. Because it's the only practical way to manage systems at the scale we're talking about. The result is, if you do the math, our systems launch somewhere around 2 billion containers every week inside Google's production facilities. Now, Urs Hulzler, our senior vice president, has this saying that when you spend 15 years working on cloud engineering, cloud infrastructure, you learn what works and what doesn't. And along the way, we've learned a lot about what works and what doesn't in cluster management. We've made probably all the mistakes that can be made. I won't say definitively, because I'm sure there's some that we missed. But we've stubbed our toes along the way, and along the way, we've learned the architecture and the patterns that work. And that's what Kubernetes is all about. Kubernetes is us taking the learnings of what works and what doesn't in managing production containers at scale and doing it in the open source. And what's really powerful is it's actually built by the same group of engineers that built Borg, our containerized system that we use internally. But where that system was built around one hardware stack, one software stack, built for the needs of one company, Kubernetes, we recognized from the beginning that that would never work. Everybody's environment is different. Everybody's needs are different. And so we knew that it had to be open source, and it had to be built with the support of hundreds and hundreds of other contributors. We did not know everything there was to know about this. We know about how to do it and scale in Google's infrastructure. We needed partners and an open source community who understand all the other environments. So the main difference between Borg, our internal system, and Kubernetes is owned by everyone. We're the largest contributor, but there are significant contributions from many, many, many companies. And we knew this was a requirement because our vision of the cloud is not one where when you pick a cloud vendor or you pick an environment that you are locked in and you can never change that environment. We knew that to be successful, you need the ability to pick an environment, and I work at Google. I hope you all pick Google, but I know you won't. And so what's really important is the ability to, no matter what environment you pick, whether it's Amazon or Microsoft or Google or on-prem or VMware or Red Hat, the ability that as your needs change, that you can move those container workloads to another system without rewriting them. And that's really the key. And what's been amazing is the number of companies that have shared this same vision. Again, we are the largest contributor, but Red Hat is second and has made many, many really important contributions. And I think the result is like metallurgy, right? You know, that when you mix metals together, an alloy is a lot stronger than any one element that goes into it. And we really think that that's true of Kubernetes, that there's combined wisdom that's greater than any of our individual companies. Red Hat, again, has done amazing work making Kubernetes enterprise-ready on day one. Other companies like VMware have also made great contributions as well. But there's lots of ways that you can manage clusters. There's a lot of products and technologies out there that are trying to solve this problem, because I think everybody sees that containers are incredibly powerful, but they're not sufficient in and of themselves. So what kind of makes Kubernetes different? Well, if I were to put it into one word, it's that Kubernetes is the only system out there that is built with the idea that you can take your workloads and port them from environment to environment. It's really the only cluster management system that you can rely on for that. If you want to run clusters of containers and you only want to be locked into one environment, there's lots of choices out there. There's lots of ways to do that. But really, Kubernetes is the only one that can actually give you the freedom to move as your workload changes. It's also been incredible to see the ramp up. You know, when we launched it on GitHub, you know, we were optimistic, I think, but I think even we were taken aback with the pace at which not only contributors joined and favorited and starred the GitHub project, but the rate at which we're getting pull requests and contributions. We're running about 200 pull requests a week, and we have over 400 contributors actually contributing real code into the project. It is truly an open source project. It's not shovelware. It's not one of those where it's open source, but somebody keeps the control all to themselves. All of the design decisions really are done in an open IRC channel. We do weekly hangouts live for anybody to contribute and to be part of those. We send out weekly summaries of those for anybody who can't make the hangouts. It really is a project being built by a community. And you're going to hear more as Craig talks about how we take that to the next step and really make sure that Kubernetes is a universal deployment target. And what's really gratifying as well is that we're actually seeing real customers using it. CloudBees has done some amazing work with Jenkins in order to really streamline their dev test cycle by moving their system into the cloud. Other systems like Shippable as well are using Kubernetes in order to increase their software development speed. We're seeing a number of customers using Kubernetes in really some high-scale environments. Porch and eBay are both examples of companies that are doing very large-scale deployments of Kubernetes. And of course, CoreOS and Mesosphere are doing great work to make sure that Kubernetes works well with their community of operating systems as well. So really work across all the communities and getting deployment in the real world. Which has led us to the point we are today, which is Kubernetes 1.0. Yes, that's for the engineering team. And when we sat back a few months ago and we said, what would Kubernetes have to look like to be 1.0? What would we feel would be a good enough base that we would feel comfortable saying, yes, this is our 1.0 product? And we hit on a couple key workloads. We really wanted to optimize for both stateless and stateful web application hosting. So hosting web apps using the common set of both stateful and stateless web services. We wanted to focus on scale-out testing as well, the ability to do testing of your applications at large scale. And we wanted to focus on that DevOps pipeline, that continuous integration, continuous deployment pipeline that's a part of any modern system. So this included things like support for DNS, load balancing, scaling, health checking, service accounts, all while making sure that we worked in a hybrid cloud world. It was important that for anything we do to be called 1.0, it has to work not just in cloud environments, it has to work on on-prem environments as well, both bare metal and virtualization. And that it was ready so that anybody who came to our GitHub site immediately got easy-to-follow samples, that you didn't have a convoluted set of steps in order to get started with it. And I'm really happy to say that as of about a week or so ago, we were able to check all these boxes and do our official 1.0 push that Brendan Burns did into the GitHub account. Of course, core functionality is important, right? And I talked about some of those, about DNS and those sorts of things. The ability to manage containers into pods. The ability to be able to say that these two containers are so intimately related that they should always be scheduled together onto the same machine. The ability to have volume management so that your containers can connect to local disks or network storage. And debugging capability so that when something goes pear-shaped, you have the ability to actually see what's going on in your system and respond appropriately. The ability to live upgrade Kubernetes environments. So that as you have new versions of your software, you can do phased rollouts or phased upgrades of a cluster while the cluster continues to run and continues to serve traffic. The ability to scale the cluster, to add new nodes, to add new capacity as the needs require, and then to reduce that capacity when the traffic dies down. And the ability to give you namespaces so that you can easily reason about things like, find me all the containers that are my development version of this application, or find me all the containers that represent my back-end system for this application. The ability to reason about your system at an application level instead of having to rely on naming conventions of machines in order to identify which machines are dev and which machines are test. And of course, performance was a key goal. We set out to have a goal of running thousands of containers, order of magnitude, across hundreds of nodes with sub 5-second deployment times and API responses. And of course, bearing in mind that declaring something 1.0 and production ready means the API has to be stable, we wanted to feel that we were through making major changes to the API and that we had a strong deprecation policy in place. So that if you build systems on top of Kubernetes today, you know that that API will continue to run and continue to be supported. So how do you get started with Kubernetes? Well, there's two ways. First of all, as I mentioned, this is fundamentally an open source project. And everybody is welcome to join the Kubernetes community via GitHub. And since this is OSCON, I assume that's what most of you will be interested in doing. Join the weekly hangouts we have. Join and talk directly to the engineers building Kubernetes across the different companies. We have an IRC channel that is very active, and not just on US time zones. We have developers on the Kubernetes community in Europe as well. So this channel is actually active many, many parts of the day. All development is in the open on GitHub. So anything you want to see. If you want to know our roadmap, you don't have to go and find a product manager and sign an NDA to find out the secret roadmap. It's all there on GitHub. So if you go to kubernetes.io, today you can get started. But some of you may be looking for production-ready, fully supported Kubernetes as well. And there's numbers of ways you can do that. At Google, we have Container Engine, which is our version of a fully hosted, fully managed version of Kubernetes running on Google Cloud. But we're not alone. Red Hat has container host with integrated Kubernetes support in Red Hat Atomic. Tectonic has a fully supported stack via CoreOS that's in preview today. Mesosphere has a fully supported Kubernetes implementation on their data center operating system. Hitachi has support through their unified computing platform. And there's many, many others. Companies that are ready to give you turnkey solutions fully supported around Kubernetes. If you're interested in those, I encourage you to check out the partner displays in the back of the room. We have many of these companies here ready to talk to you about that. So that's enough sort of as a background. I think what you're probably really interested, though, is hearing is the technical vision and roadmap of where does Kubernetes go from here. And there's really no better person to do that than Eric Brewer, Vice President of Infrastructure, and really one of the key technology leaders behind the Kubernetes team.